Hello, what's blue and not heavy? Light blue. Okay, let's get to it. Today we are continuing on, but we're being a bit more specific with transformations and in particular trig graphs. So think of this topic as the mixture of dilations, transformations, and trig graphs. Okay, now before we start, pause this video, see if you remember how to draw these three functions. Off you go. Oh, you better have paused. I'm hoping that you guys remember that there is your sine, so that means it continues on this way. Did I do that right? I knew I should have just pre-did this. That's okay. You get the idea. Oh man, I can't live with that. I will fix it. Yeah, that's acceptable. All right, and cosine, very, very similar. Cosine starts at 1, ends at 1, so that means it'd be very similar for this side here. And then tan is the real fun one. It's got this weird little thing going on with asymptotes at every pi. Yeah, essentially every pi, I think. So that means if I continue, ends up looking a little bit like this. And like that. Okay. Now that is the graph. Now, in terms of this particular topic, we're going to start giving things names, okay? For trig things, when we talk about transformations, these trig particular waves, we have subject-specific terms. There's 4 terms that I think you'll need to know, okay? The first one is amplitude, which is the height of the wave from the peak to the center. So in this case, what I mean by that is, I'll start highlighting these. Amplitude, that's from peak to the center. So in this particular case, amplitude is equal to 1. Okay. The second one here is I got a period, and a period just means it's how long the wave takes to complete one full cycle. Okay, now for the period, I'm going to show you on multiple things. All right, you can see here from negative 2 pi to 0, that takes one full rotation. I could also do the same thing. And hopefully if I've done this good, which I clearly haven't. Okay, so what I'm saying about period is you can see that that's start to end, that's one full rotation. But what I can also do is I can move it here, and that's also one full rotation as well. See, we go from peak to peak, or we could even go from bottom to bottom, but that completes one full cycle of the wave before it repeats itself. Okay, that's what it's meant by period. So that's your period, and in this particular case, your period is 2 pi. Okay. For looking at this one here, I go between minus pi on 2 to pi on 2. This period here is just pi on 2, right? And it repeats itself. Oh, sorry, not pi on 2, just pi. And it repeats itself every single pi. Okay, so every pi that goes on, we repeat the thing. So that would be the period for tan. Okay, I'll get back to why that's important. Now your phase is just a simple way to say what happens if I translate it to the left or to the right. So for example, if I took this beautiful graph here, this cosine graph, and what I did was I moved it maybe to the right a little bit, and then I joined it up. If I moved it like that, that would be what we call a phase, if something's shifted left or right. Okay, you'll figure out that I think sine and cosine is just one's a phase of the other. But the idea is if I move left or right, that looks like sine, doesn't it? Okay, but for now, we recognize a phase as a moving of left or right. Okay. Now, those are your 4 kind of things. And the last one I should probably talk about, I'll do this one in maybe red. Now, equilibrium is just a fancy way to say it's the center of the wave. It's a mean value. They call it different things, but for us, all these ones here, they're right on the y=0 line. Okay, they're dead center, and that there is the center of our wave. Now, these are your most basic ones, y equals sine x, y equals cos x, y equals tan x. But we're just going to transform these, and it's not going to be light. I'll show you what we're going to transform. Yeah, we'll get there. We're just going to transform these graphs, dilate them, shift them left, right, up, down, translate them. That's the idea. Now, a couple things to note here. If what I'm going to use is, I think this is the easiest way to think about it. I want you to remember this form here, okay? Not given on your reference sheet. This is something that you'll have to remember. It's just a nice way. Sine x is your most basic. This is as complicated as it can get. Okay, you've got something out the front of your sine. You've got something kind of in front of the x. You could have like another term that's attached to this bracket, and then you can have a final term on the outside. Okay, so whether it's sine or cos, these two are the same. So amplitude is whatever your coefficient of the whole thing is. Okay, your equilibrium, so where we shift up and down, that's your last letter here, that's your D, okay, which is kind of similar to D is just a vertical shift. So if I'm moving the whole graph up or down, that will be that. Now, we saw before with sine and cosine, what is our period? Okay, period of sine is 2 pi, period of cosine is also 2 pi. That's how long it takes to complete one full rotation. So what's nice about this is your period is given by 2 pi over whatever the term in front of x is. So 2 pi on b. Okay, now if it's just bx and there's no plus c, then there's no phase. If there's another term attached to your x term in the bracket, that's how you'll know there'll be a phase. Okay. Now take a look at tan. Tan is very, very similar, but slightly different. Now, tan is true to form, always the slightly different one. Everything here is the same, A at the front, B with the X, a random plus C, and then a plus D at the end. Amplitude is still A, equilibrium is still D. Now your period, instead of 2 pi on B, which it was for the previous two, we noticed that before our period of tan was just singular pi. Okay, that means after every 180 degrees, it would repeat itself. So that's why for your period here, instead of 2 pi on B, it's just pi on B. And again, your phase is related to your plus C. Okay, now let me break down what a question like this might look like. I've only got one question. We'll break it down. So this is there's a lot going on here, but what we need to recognize is it's going to be in the same form we talked about. It's in some form of A cos bx minus or plus C technically plus D. Okay, that's what our form is. And so from here, we can read a couple things off. First of all, we know the amplitude. I can read that straight away. Your amplitude is A. So in this particular case, our amplitude is going to be 2. Okay, the next thing that we've got our equilibrium, center of motion, mean value, whatever you want to call it. We know that that's going to be, excuse me. Let's zoom back in. This one here, you can see it's D. So that means D is going to be 1. Our equilibrium, our center of motion has just been moved off from 0 to now 1. Okay, now because it's cosine, how do we find the period? The period is going to be 2 pi over B. Okay, now B, you can see in this case is 2. So in other words, my period is going to be 2 pi over 2, which means pi. So that means every pi, I'm going to complete one rotation. And the last thing that we've got here is, do we have a phase? In this particular case, we do. We've got something to do with that minus pi on 4. That is going to affect our phase. Okay, so sketching this, there's a lot going on. Let's break it down one thing at a time. Okay, and sometimes what I end up doing, you know what, just to show you, what I would do is I would translate it or transform it one step at a time. Okay, so I've got all these different ones here. And let's start with this. So we know, first of all, it's cosine. So let's start with y equals cos x. And I know it's just going to look like this. 2 pi, 0 pi. Okay, so far so good. Now let's add the next thing, which I know is the amplitude. Okay, so now instead of peaking at 1 and -1, it's still going to look the same. It's still going to start at 0, end at 2 pi. But in this case, it goes all the way down to -2 and 2 because that's my amplitude. Okay, I've extended it that way. Okay. Next thing to go from here is let's adjust the period. So the period means how often things happen. So in this particular case, our period is now pi. So that means I repeat every pi. Okay. So that means within 0 to 2 pi, I should repeat myself twice. So 2 cos 2x is going to look a little bit like this. I need a center kind of mark here. So that means I should do that. I should do that. That means I repeat myself every pi. Okay. So you can see that I'm adding on layers to this. And now what I'm going to do is let's add the phase. So now I've got y equals 2. I don't know why I'm going so close to here. Let's continue on over here. So now the next thing I'm going to do is the phase, which is y equals to 2 cos 2x, and we said minus pi on 4, did we? Yeah, minus pi on 4. So that means sketching my graph here, the easiest thing might be actually just to draw it. So there's one. That's so bad. Okay. Let's pretend I actually drew it well. And I'm going to label it so you can see exactly what I mean. Let's say that there's pi, that's 2 pi, that's 0. And so that would make this pi on 2. That would make this pi on 4. And then I could keep going. That's this one here would be 3 pi on 2 here. But the important part here is you can see that there's a pi on 4. Now, if I'm minusing, that means instead of shifting to the right, I'm actually shifting to the left. So this is where you can get a bit creative. And what I'm going to do is I'm just going to shift everything back. So where it was pi on 4, I'm going to move that back until, so it was here. I'm just going to shift that back and phase it until that point that was there is now hitting your, does that make sense? That point that was there is now at the 0. Okay, so now we've just lined it up and we've shifted the whole thing, the whole graph back pi on 4. Okay, now what we'll need to do is if we're asked to draw it between 0 and 2 pi, we're just going to have to finish that off until we hit 2 pi. And that will be our new graph. We've just phased it. And then the last step here, I'll just add the +1. So hopefully if I've done this right, just make a duplicate. I'll make it in red. And I'll shift it. If that's where it was originally, I'm going to shift the whole thing up by 1.